All right, welcome back to AI Unlocked, Day 9. Yesterday, we got machines to understand language. Today, we're going to teach them how to see. This is computer vision, and honestly, it's one of the coolest, most mind-blowing parts of AI. It's already everywhere, from the filters on your phone to tech that might literally save lives.
So let's just jump right in with the big question. You look at a picture and you instantly see a happy dog, right? But a computer, it looks at that exact same image and just sees a massive grid of millions of numbers. So how in the world do we bridge that gap? How do we get from a sea of raw data to, hey, that's a happy dog in a park? Well, that's the magic we're unpacking today. Okay, first things first. We need to get our heads around how a computer even represents an image. Because I promise you, it is nothing like the way our own eyes and brains process the world.
And this is really the fundamental truth you have to grasp. To a machine, a beautiful photograph isn't a picture. It's just a highly structured spreadsheet of information. That's it.
Each tiny little dot in that grid is called a pixel. Now, for a simple black and white or grayscale image, each pixel is just one number, maybe 0 for pure black and 255 for pure white. But for a color image, each pixel actually gets 3 numbers, one for red, one for green, and one for blue. So a bright red pixel might be something like 25500.
Now here's where it gets kinda crazy. A single, pretty standard photo from your phone can easily have over 2.3 million of these individual color values that the computer has to somehow understand. Making sense of that absolute ocean of numbers? Well, that's the core challenge of computer vision.
And it is a huge challenge. I mean, think about it. The same object can look totally different depending on the light or what angle you're looking from. And we've all seen that meme, right? The Chihuahua versus the muffin. To a computer, those can look shockingly similar. Then you throw in messy, cluttered backgrounds and objects blocking each other. Yeah, you can see why this is such a tough nut to crack.
So, how did we crack it? Well, the answer lies in a special kind of neural network that we've talked about before, the convolutional neural network, or CNN. You can basically think of these as the eyes of modern AI.
The key operation in a CNN is something called convolution. The best way to think about it is like this. Imagine you're sliding a tiny little magnifying glass across the entire image. This little magnifying glass, which we call a filter or a kernel, isn't there to make things bigger. Nope, it's designed to look for one very specific, very simple pattern, like a vertical line, or a patch of green, or a gentle curve. This whole process works like an assembly line for understanding. The very first layers use all those little filters to find super basic things, like edges and colors. Then, deeper layers take those simple patterns and start combining them into more complex shapes, like an eye or a wheel or some fur. Along the way, pooling layers shrink everything down, kind of like summarizing, just to keep the most important bits. And then finally, at the very end, the network looks at all the complex features it's found and makes a call. Okay, I see fur, a snout, and 4 legs. I'm 95% sure this is a dog.
And this approach, it kicked off a complete revolution. Back in 2012, a model called AlexNet proved this method could just smash all the existing records. A couple of years later, VGGNet showed that making the networks deeper made them even better. And then ResNet came along in 2015 with a mind-boggling 152 layers, solving the problem of how to even train these massive models. The progress was just unbelievably fast.
Okay, so now that we have a feel for how AI sees, let's talk about what it can actually do. Because it's not just about saying what's in a picture, it's about different levels of understanding.
So, starting simple, we have image classification. You give the AI a picture, it gives you back one single label: dog, car, pizza. This is the kind of tech that powers your search in Google Photos.
Now let's level up. Next is object detection. Here, the AI doesn't just tell you there's a dog in the picture, it actually draws a box around it to show you exactly where it is. This is absolutely essential for things like self-driving cars, right?
And for the most detail possible, you've got image segmentation. This is where the AI outlines an object down to the individual pixel. It's not a box anymore, it's a perfect silhouette. This is super important for medical imaging, like finding the exact border of a tumor, and even for photo editing features, like that remove background button on your phone.
And the list of what AI vision can do just keeps growing. We're talking about face recognition to identify specific people, pose estimation to track the joints of a body in motion, and even optical character recognition, or OCR, which lets an AI read the text right out of a picture.
And look, none of this is science fiction anymore. This technology is already baked into our world in so many ways you might not even realize. Let's just look at a few.
In healthcare, AI is analyzing medical scans with an accuracy that can match or sometimes even beat human experts. In farming, drones are using it to check on crop health. In stores, it's what makes cashierless checkout possible. And of course, in entertainment, it is the magic behind every single one of those real-time AR filters you see on social media.
And if you want a sense of the sheer speed and power we're talking about, get this. A self-driving car uses computer vision to analyze everything around it, pedestrians, cars, signs, lane lines, up to 60 times every single second. It's just an incredible amount of real-time processing.
But you might think, okay, CNNs, we solved it. The story doesn't stop there. Just when things seem to be settling down, a whole new approach arrives. And the next evolution in computer vision is something called the vision transformer.
So, remember how CNNs are like that little magnifying glass sliding across the image looking for local details? Well, vision transformers, or ViTs, do something completely different. They break the image up into a grid of patches, kind of like puzzle pieces, and then they analyze the relationships between all of those pieces at the same time. It gives them a much more global, holistic understanding of the whole scene.
Now, this change in architecture is a really big deal. Why? Because that same transformer design that's taken over vision is the exact same one that completely took over natural language processing. And this convergence is leading us to true multimodal AI, a single, powerful model that can understand and reason about images and text together.
So we've done it. We've unlocked the ability for machines to see and interpret our world with incredible speed and accuracy. From spotting diseases to driving our cars, the potential is just immense. But this leaves us with a huge and very important question to think about. Now that our machines can see, what